Hello, everyone, and welcome to Learning with Jelly. So, today is going to be our first crash course for those who are trying to get into the field of data analytics. Now, I've been getting a lot of messages about Jelly. Do I really need to know Python? If I do need to know Python, how do I even get started? What are some of the skills that I even need to know in order to become a data analyst? So, I decided to make a crash course for you. Now, if you like this course, since this is part one, please like and leave a comment below, and we can make part 2, 3, 4, etc. And whatever we need to help you all get into the field of data analytics. Now, in order for you to actually follow along, I have made a GitHub repo for you to clone down. If you do not have a GitHub account, please go to github.com. It is free. Set up a free account. That is a great way to store your data analytics or data science work so that you have a portfolio to show employers. So, let's go ahead and get the repo. So in the description below, you're going to have a link to this GitHub repo. It's called Intro to Data Analytics _ Learning with Jelly. So in this repo, we have 2 notebooks so far. We have part 1, which is what we're going to work on today. And there's also the solution. So for those who want to go back and look at the answers, there's also a solution notebook as well. But first things first is you need to copy this down. So if you scroll down in my README, I tell you the steps that you're going to need in order to get these notebooks. So once you create your GitHub account, you're going to fork this repository and then you're going to clone your fork. So what that means is once you hit this fork, and I'm the owner of the repository, so it's no need for me to fork it, but it's going to create a copy of my repo to your GitHub account. And you know that it's successful when you see your username instead of mine, which is ASPRATLE. Okay, so if your username is John Doe, you would see John Doe here, and then you know that you have properly forked your repo. Once you have forked this repo, you want to click on your repositories so that you see that forked repo, and then you're going to hit code and you're going to copy this URL. Okay. And this is what we call cloning it down. So I'm going to copy it. And then I'm going to go to my terminal. So if you are on a Windows, your terminal is going to be Bash. If you are on a Mac, your terminal is going to be Terminal or a ZSH shell. You can just go into apps down below, and then you should be able to type in terminal and you should see it, okay? But we do not. I already have my terminal open, and I'm going to go to shell, a new window. As soon as I see a new window, I see my terminal comes up, which is ZSH. And I'm going to go ahead and make this terminal super big so that you all can see what I'm actually typing. So the first thing that I want to do is find a place on my computer where I want to store my notebook. So maybe you can create a folder. So let's go ahead and do that. So I'm going to do CD, which means change directory. And I'm going to go into my documents folder. And within this documents folder, I'm going to make a folder called Analyst. Okay. And this is where I'm going to store these repos. So mkdir just means make directory. Once I make the directory, now I have to navigate within that directory. So now I'm going to hit CD and I'm going to type in Analyst. If you tab over, it finishes for you. A slash at the end means that it's a folder. And now you can see that my directory has changed to Analyst. So now I'm going to list, and it should be nothing in this folder. LS means just list out the contents, and that's good. I have a blank folder called Analyst within my documents. So now I'm going to go ahead and clone down that repo from my fork. So I'm going to say git clone, and I'm going to paste. So I did Control V for a Mac. Okay. And here now, when I click LS, I should see that there's a repo called Intro to Data Analytics Learning with Jelly. So there, it's cloned to my computer. So now I can type in Jupyter Notebook after I install Anaconda. So you can go to anaconda.com, and anaconda.com is an installation. And when I open up Jupyter Notebook, it's going to take me right to a Jupyter Notebook, and I have these two files. Okay, so that is how I'm able to access the data file. So if you need to go back through the steps, go back through the steps. I will say it may ask you for a password. If you need a password, that is actually going to be a key. So you're going to click the image of you. You're going to go to settings. You're going to go down to developer settings. Go to personal access tokens, hit tokens, and you want to generate a new token. Once it generates a new token, okay, that is going to be your password. So if it's prompting you for a password in your terminal, that token will be your password. So once again, you're going to click on your face, go to settings, scroll down to developer settings, personal access tokens, generate new token, and you want to set an expiration date and just check repo, and then you're going to generate a token. Okay, so that is how you are going to have access to the actual notebook. So let's go ahead and get started. Okay. All right, so Pandas. So what is our agenda for today? So we just went over how to fetch down the repo from GitHub. If you got lost or if you're on a Windows and you need more support, definitely look at GitHub's documentation or just go on YouTube like you are now and put how to fetch down a repo from GitHub. That should help you. We're going to talk about the Jupyter interface. So we're going to be utilizing a Jupyter notebook for this. So we're going to talk about some hotkeys with that. We are going to go over pandas and what that actually is, read in data, explore some data, get in some statistics, get some visuals going, create variables, drop variables, and then write out our changes to a CSV file. So we're going to do it all. Feel free to skip ahead if you already know certain parts. Okay, so Jupyter, if this is your first time in Jupyter Notebook, there's tons of hotkeys that you should know. If you're uploading this notebook into Google Colab, which is a free interface where you're able to collaborate with others on the notebook, they have the same hotkeys as well. So if you click escape in an A, that is going to add a code cell or a markdown cell above where you're at. If you do escape B, it's going to add a cell below. Escape double D is going to delete a cell, etc., etc. So those are the most important hotkeys that you should know. You also should know that shift return or shift enter, I think on a Windows, allows you to run a certain cell. If you need to know any of the shortcuts, all you have to do, and let me exit out of this real quick, is go to help in keyboard shortcuts. And this tells you exactly all of the keyboard shortcuts. You always can run a cell by hitting run as well. You always can add the plus sign to also insert a cell if you don't want to use hotkeys. Okay, so those are some hotkeys. So let's go back to where we left off. Okay, so we got our repo down from GitHub. We know the hotkeys. Now let's talk about this pandas. Maybe you have heard it on LinkedIn. Maybe you're a student getting started and your professor is talking about pandas and you're like, what is this thing? So pandas is one of the most widely used packages in data science and in data analytics for data manipulation and data exploration. So it allows you to explore your data. Do you have missing values? What is the type of columns in your data? How many rows and columns do you have? What are some statistics on your data? How can you visualize your data? It's very robust and it's actually built off of the NumPy package, which stands for numeric Python. And we can go through that package in another video. A package is or library, you may hear people say both, contains classes, objects, methods, and attributes. So a package contains a lot of information. And when we look at the documentation, you're going to see how much information it actually contains. But why do we use packages? Because we don't want to keep writing a whole bunch of code. Right? So packages helps us not reinvent the wheel. So we can use code that developers have already made for us that have been packaged up oh so nicely. So packages help us do modeling, data exploration, visualizations, evaluation of models, and a whole bunch of other things. So Pandas have these two main objects that we're going to talk about today: data frames and series. And it's important to know that everything in Python is an object. And I'm going to show you exactly what I mean by that momentarily. But we're going to be focusing a lot on data frames. Once your data is in a data frame, you can do wonders. Data frames are just 2D matrices that has rows and columns. Okay, 2D, two dimensions. I have rows and I have columns. And a series is just a single column within that data frame. As I mentioned, Pandas is built off of NumPy and it has documentation. So I'm going to click on this documentation link, and you definitely can go to pandas.pydata.org, and it's going to give you a lot of documentation. But as you can see, these are some groups of documentation. So they have general functions, they have the series object that I just mentioned, they have data frames, they have plotting of data, etc. And when I expand the data frame, I see all of these methods and or attributes. So as you can see, there is tons of documentation about everything that you can do with a data frame using Pandas or with a series. Okay, series has tons of methods and attributes as well, right? And we're going to refer to this documentation as we go along. Okay, all right. So let's keep going. What is this object? Okay, like I said, everything in Python is an object. And if you can get used to that and understand that, it's going to make things a lot easier as you learn how to become a data analyst or a data scientist. So models are objects, packages are objects, variables are objects. And Python is considered an object-oriented programming language where you can manipulate an object a certain way to get out a certain result. So objects are part of classes, and objects have specific methods and attributes. So what do I mean by that? So when I think of a class, I think of a teacher that has a class, and that class could be history class. Some objects inside of that history class would be students. So it'll be student 1, student 2, student 3, and so forth. Each student have methods, which you can think of as actions. Some of the students may be sleeping, that's an action. Some of the students may be writing. Some of the students may be texting. And some of the students may have attributes. Some of the students may be short, some may be tall, some maybe have black hair, etc. So you can think of objects like that. Based off the object, that determines what methods and attributes it has. So you can think of methods as actions and attributes as characteristics of the object. As said in the previous slide, we'll be using methods and attributes that apply to two types of objects: data frames and series. So let's look at this again. I drew this visual here. So this is property of learning with Jelly. I'm very proud of this visual. And I have a class. It is a class of sports balls. So it may have tennis balls in there, soccer balls, footballs, ping pong balls, etc. But what I'm showing here is a basketball and a baseball. These are two separate objects within the sports balls class. Now, the basketball has certain methods. And these are actions. I can bounce a basketball, I can shoot a basketball, I can block a basketball, etc. And methods a lot of times is followed by this set of parentheses. So notice that. Normally something is a method if it has a set of parentheses at the end. And you're going to also see that in code. Now, on the baseball, I have two different methods. I can pitch a baseball or I can hit a baseball, which I'm not going to say that I can hit a basketball. So, because these are two different objects, they have different methods, or they may share certain methods as well. So, I can roll a basketball technically, just like I can roll a baseball. So there may be some overlap in methods with objects, but some methods are just specific to that type of object. So attributes are these characteristics and properties. So as I can see, both basketball and baseball has the attribute of color. And if I were to run this in code, I should get out orange for basketball and white for baseball. But basketball has an attribute that's number of lines, and baseball has pitch angle. So as I mentioned, you can have some overlap between methods and attributes because people don't like to reinvent the wheel. However, there are always objects that have specific methods that only correspond with that object. So there's certain things that you can do to data frames that you can't do to series, that you can't do to models, that you can't do with integers. Okay, because data frame itself is its own object with its own methods and attributes. Now, how do I learn these methods and attributes? Practice, or I look at the documentation. Okay, so this is an important side note to know all about object-oriented programming because it helps you as you're actually reading documentation into code. Okay, so what data are we going to be using in our first project? I'm so excited. So hopefully you're following along so you can push this project to your portfolio. If this is your first project, you can say this is my first project and share it. It's awesome. So we are going to be using a student's data set taken from Kaggle, okay? So I have the link to the data set here. So when we click on that, this is what we get. Okay. And this is fictional data. It says it at the top. So for those who love to use Kaggle data sets, it's great, right? But make sure that you're actually reading all about the data set to see if it's a fictional data set, what is the data set all about, etc. So here the goal is to predict whether or not a student will apply for graduate school. It has different columns when we scroll down about the class that they were in. It has a race column, gender information, GPA information, and all of their mathematics scores. So mathematics as well as verbal English scores are the two main scores that people normally use for entrance into college. If you're in the United States, it is on the SAT, it is on the GRE, it is on the MCAT, math in some type of language, right? So this is a data set that's going to have math performance, and we're trying to predict whether or not a student is going to apply. So our target is shown here. We're going to see that in the data. 0 means that the student did not apply to graduate school. 1 means that they apply for a graduate school within their country. And 2 means that they apply for a graduate school internationally. It also gives you some information about these 4 columns at the end of the data set, form 1, form 2, form 3, form 4, where these are indicators of a student's background. So 0 means more wealth, 4 means more poverty. So these are interesting things to note. They also have information about the gender and race, but as we see, race is censored. So this is the type of data that we're going to be utilizing today for our analysis. So fictional data set, and the goal is to analyze whether or not a student is going to apply for graduate school. Race is a censored feature to protect privacy. So when you're working with data, you may have censored features, but it still may be useful. It doesn't mean that you go ahead and drop it. because maybe you can educate people about the bias in the data, etc. Assume that the higher scores that you see in your math columns mean better academic performance for that math subject. We already talked about forms 1 through form 4, and the target variable is Y. 0 means that you failed to apply, 1 that you applied within your country, and 2 you applied abroad. So that is the data that we're going to be working with. Okay, so now for the fun part. We're going to read in this data set. So I'm going to go back here. So when you actually clone down the data is inside the data folder. Okay. And it's very important you know what a directory is, because that is how Python is going to locate the file. So we see that it's in the data folder and the file name is students.csv. Okay. If I wanted to point for an image, I would put image / the image name. Okay. So first thing, let's read in that CSV file as a pandas data frame object. Because remember, the goal is to get the CSV file into a data frame so we can explore it. So first things first is we are going to actually import pandas. So I'm going to add a cell above by doing import pandas as PD, because this is our package. And notice that the PD is just an alias. All that this means is so that I don't have to keep typing pandas over and over and over again. If I want to use a function within the pandas package or method or attribute, I can just type PD. Okay. So the first function that I'm going to use is this read underscore CSV. They have read underscore Excel if you want to read in Excel. And as I mentioned, it's in the data folder and it's called students.csv. And this needs to be a string. A string is just text data that's surrounded by single quotes. So I'm going to run the package first, and then I'm going to read in my data. And I know that it ran because I see a nice little 1 and a nice little 2. Okay. All right, so we read in our data. So now let's explore the data. So we're going to use methods. Remember, those methods are those actions that we can take on the object. What is the object called? The object is called students, okay? So I created a data frame object called students. So how can I make sure that it's a data frame? So let's do escape and below, or escape and B. Oh, it's not adding a cell for me. That is perfectly fine. I will do it on the next page. Oh, it added it here. So let me delete out some of these. Escape double D. So in this case, I'm going to say type, and I'm going to type in students because that's what I saved it as. And I see that it's a data frame. Okay. So I want to make sure that I have the right object type, because based off of the objects, you have specific methods and attributes. Awesome. So we're going to explore the data frame object using methods first. Remember that many methods end with a set of parentheses and they perform some action. So the first thing that we're going to do is look at the top and the bottom of the data frame. Okay, so in order to look at the top of the data frame, we're going to call the dot head method on the data frame object called students. So it's as easy as calling your object name and then calling the function right after. So when we run this, by default, dot head gives us the first 5 rows of our data set. So in this case, I see all of my columns and I want to see if anything sticks out to me immediately, right? I notice that race looks like a number, so that may stick out to me immediately. Maybe I have a data dictionary for it, or in our case, it's censored, so I want to keep that in mind. I also see GPA is a float, which means that it has decimals. Everything else seems pretty numeric for our classes. I also see those form 1 to form 4 variables, as well as my Y that we just explored in Kaggle. Okay. So if I wanted to explore or just visualize the first 2 rows, I can put a 2 here and I get out the first 2 rows. And it's as easy as that. So that's how we look at the top of our data frame. How do we look at the bottom? We just call a dot tail. Okay, so I'm going to call a dot tail. And here, instead of seeing 0 and 1, these are called my index column. I see 104 to 103. Python always starts indexing at 0. Okay, so it's not 1, it's 0. And here, I'm just making sure I don't have any missing data. I'm looking at anything that sticks out. Okay. So if I want to explore the top and bottom of my data frame, I'm using dot head or dot tail. And I definitely can put a number in dot tail as well. Okay. So now let's explore some information about our data. We know what the top of the data frame looks like. We know what the bottom of the data frame looks like, but let's run a dot info. So can you think about how you can code this? Remember, we have data frame name, a dot, and then the method. So in this case, the data frame name is students. Then we have dot info. And it's a method, so we're going to put those parentheses at the ends. Now, Python is case sensitive, and you need to spell things correctly. So normally, if you run a cell and you get a name error or anything of that, most of the time that means that you misspelled something or you capitalized something that shouldn't be capitalized. So keep that in mind. So I'm going to do my dot info, and wow, look at how robust this method is. What does it tell me though? Right? What does it actually tell me? Now, it tells me that I have 105 rows. It tells me I have 17 columns. It tells me the column names. It tells me non-null counts. That means how many nulls, how many completed observations do I have? And all of this is 105. If I had any missing values, this number would be less than 105. It'll be like 100 or 90, right? Then I would know that that column has certain missing values, but this one doesn't. It tells me the type of column, right? Notice I have some objects here, which is normally categorical or text data. I have some integers, which is normally whole numbers. And I have some floats, which is decimals, floating point numbers. And sometimes when I'm doing certain analysis like linear regression hates objects. You can't use objects. You have to create dummy variables. And if you all want me to go through how to explore pandas and creating dummy variables or sklearn, we definitely can. Okay. So dot info tells me a lot. Okay. So now I say, what all does this method tell you? Are there any missing values? Do the data types make sense? Right? To me, it doesn't make sense that race is an integer, but when I looked into the data source, it told me that race would be an integer for censorship, right? So in order for you to write some markdown, you double click in this box. Okay. And you can write out your main takeaways. You want to do as much documentation as possible as a data analyst so you can know what to explore. So you can say this set has 105 rows, multiple data types, no missing values. And you can hit shift return or shift enter, or it could be control enter on a Windows to run that cell. Awesome. Great, great, great. So those were our methods, dot head, dot tail, and dot info. So now since we looked at some methods, what are some attributes? Remember, attributes are those characteristics or those properties of my object. I'm still talking about the object of data frames. So right now, the object of data frames can show its head, it can show its tail, and it can give you some information. But it also has attributes, some characteristics of the data frame. And the first attribute that we're going to look at is dot shape. So let's look at that. So students dot shape, and I'm going to run this cell. What do you think this tells you? Remember I said data frames is technically a two-dimensional matrix of rows and columns. And this looks like something that we saw in the .info, right? We saw that it had 105 entries and 17 columns. So the dot shape just returns the number of rows and columns that you have in your data frame. Great. So now let's look at the columns attribute. What is that output? So let's type this together. So once again, we call the object students. That's our object. The attribute is columns. It's an attribute, don't need any parentheses. When we run that, it gives me a list of column names, something that I also saw in the .info method. So .info has some built-in attributes within it, right? So I just love .info because it gives me all of this within just one line of code. Okay. So notice that some of the columns are lowercase, some are proper case, some are capitalized. When you're calling out columns, you want to make sure that you call it exactly how it is spelled, exactly in the proper case. If it has any spaces, you want to make sure that you put the space in there. Python needs to have all of that. Okay? Great. So that was step 3, using some methods and attributes to explore the data. But now let's get into some statistics. And statistics is very important. The two main maths behind data science is linear algebra and statistics. Linear algebra is good with the NumPy package. We can have some statistical summaries here with the using Pandas, but there's also some other statistical packages in Python as well. So summary statistics usually include the counts, min, max, standard deviation, percentiles, and more. It's important to look at summary statistics across many subsets of your data. So looking at it by gender, looking at it by class, looking at it by location, etc. One of the most powerful methods to look at statistical summaries is .describe. So let's look at that. And by default, .describe is going to give you summary statistics on numeric features. Okay. So the first thing is I'm just going to backspace that .t for right now and run a regular .describe. And this is what I get out. I get out my numeric columns and I get out some summary statistics, the count, the mean, the standard deviation, the minimum, and some percentiles. And I'm going to see if anything sticks out. Now, standard deviation is like the spread of my data, right? So it can tell me that I have like a bigger spread within that one variable, which may be unique to me. It seems like calculus is showing a lot of spread, a high standard deviation. If I look across all of the subjects, it appears that statistics has the highest average score. So it looks like students overall are doing well in statistics, right? So those are some things that we can get out with a .describe. I like to put a .t at the end so it can transpose this table, right? So when I do a .t, instead of it cutting off on the side of the screen, I can put the columns on the rows and my statistics on the columns now. So here, now when I look down the mean, I can easily see, bam, students are doing the best in statistics and students tend to do the worst in calculus 1. Okay. I can also get some max values and some percentile information. So .describe. Okay, let's look at a crosstab function. So if you're familiar with pivot tables or anything of that nature, or frequency tables, this is going to make a lot of sense to you. So we're going to use the crosstab function, which we're going to call out two columns. And how you call out a column within a data frame is going to be the name of the data frame, followed by brackets, because that mostly means index. Like we want to pull out that index, and we're going to pass the column name as a string. So it needs to have single or double quotes around it. So we're going to create a crosstab of gender and class. Okay. So notice here, it is a function, not a method. So I'm going to do pd.crosstab. Most functions, you're going to put the name of the package in front of the function versus the methods. So let's just go back a little. The methods that we have, you're going to put the name of the object in front of the method. Okay. So let's go ahead and go back to our function of crosstab. I have pd.crosstab and I have my two columns here. Students bracket gender, students bracket class. And when I run this, I get out a nice little frequency table. So what does this tell me? After you run everything as a data analyst, you need to think about what is the main takeaway or what is the story behind it. And I see that there aren't a lot of males in class B, right? And I see that there's more students overall that's taking class A. This may be interesting to me. Maybe class B is a summer class, so not as many students signed up for it. Who knows? Or maybe class B is all of the sophomores, and maybe class A is a freshman base. Who knows? So those are things that you want to explore and look into. Outside of doing the crosstab, we could do a group by. And the group by method is going to give us summary statistics of a categorical variable. And it's going to give us that by the different levels within that categorical variable. And if you pair the group by method with the dot mean, the dot max, the dot sum, or any other statistical function, it's going to give you that across all features. So let's look at this for class. So it's a method. So now I'm back to having the data frame in the beginning. So students.group by, I want to look at the class and I want to get the mean. Okay. And this is just yelling at me for my Python. It's saying mean is deprecated. Okay. So you can put numeric only equals true in order to kill this warning, but it's just a warning. It's not an error, but I'm going to listen to it and I'm going to put in numeric underscore only equals true. And it took it away. Okay, so sometimes these warnings that come up in Python, as you get used to reading them, you'll know exactly what to do, including errors. So as we see, I have two classes, A and B, and it's giving me the mean. Okay, broken out by each one of those classes. So it looks like class B on average has a lower calculus 1 score, but a higher calculus 2 score. And if I really want to see if these were significant differences, that's when we get to running the t-test, or in ANOVA if I have 3 or more classes, right? So statistics is very powerful for insights, but we'll talk about hypothesis testing down the road. Now, what if I wanted to do the max, right? So I can group by class and let's do dot max. And here it goes. It looks like I have some stellar performance across all classes. So I have some great students in both classes, right? What if I wanted to do, and it's going to do the max of categorical variables here. M comes later in the alphabet than F. So that is why the gender is coming up as male. It's not because male is the max amount of students, because we saw in crosstab, male is not the max amount of students. So be careful how you actually interpret your output. Okay. So, and then I can also, if I wanted to do a dot count, right? And I can see both of these numbers that would add up to 105, right? Because that's how many rows we have. So I can also do gender, and I could do dot mean to see performance across gender. And of course, we get that same warning. So let's do numeric only equals true. And here by gender, I can get the mean. So it looks like on average, males are performing better than females, but are they performing statistically better? We don't know until we run a t-test, right? But this helps us give us a lay of the land. So explore everything and write down notes about things that stick out to you. What is important? Okay. So we did a dot crosstab, which was a function in Pandas. We did the dot group by, which was a method on our data frame. So now let's do a value counts, which is also pretty much like a method, okay, within our categorical variable. So in this case, I want to look at the Y variable. Remember, Y tells us if a student applied for grad school or not. So I'm going to call my name of my data frame, call the column in quotes that I want, which is Y, and I'm going to do a dot value counts. In here, I say the majority of my data set didn't apply for grad school. And maybe those who didn't apply for grad school, I may want to locate so I can help give them job coaching. Or if maybe they do want to apply for grad school, but they need help with their recommendation letters or their standardized testing. So this is going to help us figure out who to intervene with. And then I have equal amount of people that applied nationally, which is a 1, or internationally, which is 2. I could do the same thing with gender. And I see that I have 68 females in my data set and 37 males. This is a pretty small data set just for exploration purposes. But if this was like a healthcare data set and I was trying to recommend a medication across both genders, this may be something to consider, right? That maybe my model didn't learn enough about males, right, for me to deploy this out. So a value counts is going to give us accounts of each level within a categorical variable. Also a very powerful data method. Okay, so we have explored our data. We got some statistical summaries. We did the dot head, we did the dot tail, we did the dot info, dot describe. You're becoming a pro with all these methods and attributes. So now let's visualize the data. And we're going to bring in 2 additional packages to help us visualize the data. Matplotlib is the foundational data visualization package. Seaborn is like the fancy aunt of matplotlib, okay, where it's going to give you a lot more fancier visuals. You can also plot using pandas. And why do we even visualize data in the first place? That's to help us tell stories, and data storytelling is very important to move your stakeholder, right? To do some type of action. Visuals alone isn't the story, but you can add stories to the visual, okay? So we are going to use Pandas, Seaborn, and matplotlib just to get a taste of all 3 to help plot some visuals. All 3 of these packages have documentation. So you want to make sure that you go online and look at the documentation. So let's look at a bar chart to visualize that class and gender crosstab that we created early on, right? So the first thing that I'm going to do is I'm going to import the packages that I need. We already have pandas, but I'm going to import matplotlib, specifically the pyplot module, and I'm going to alias as plt and also seaborn. Okay, so I'm going to take that cross tab again, and remember the cross tab is a function, so we're doing pd, and I'm going to pass in those 2 variables that I want, which was class and gender, and I'm going to do a bar chart in pandas. And how I do that in pandas is just adding a dot plot kind equals bar, okay? And when I do that, I get out a nice little bar chart, okay, to help me visually see what's going on. And here I can see that I have more females in both classes. It both looks like it has equal ratio of female to male in each classes. And I can see overall that class B has less amount of students, okay? I can also change gender, let's say to race, even though it is an integer. We know that it's categorical, right? It's just censored. And I see that I have 7 different races. And by far, race 1 is dominating both of the classes, right? So that may be something interesting for me to look into, okay? So if we want to plot in pandas, we're going to add that dot plot, and it's easier when you're doing a bar chart to just do a dot plot next to a cross tab. Okay. Okay. What about, let's keep going. Oh, I thought we had more visuals. Oh no, what happened to our visuals? Let's exit out real quick, make sure that we didn't save. Okay. So when I exit out, for some reason, it didn't want to go in the slide deck. That's perfectly fine. Let's create a box plot of the GPA feature in Seaborn. So because it's seaborn, I'm going to use SNS. I'm going to do box plot, and I'm just going to pass in the column that I wanted to plot. And in this case, this is my good old box plot, right? Where I have my median or my 50th percentile as this middle line of my box, right? In this case, I have my min, which is 70, my max here, my 25th percentile is this corner here, my 75th percentile is that corner. And then anything that has like a diamond is an outlier. So, do we have any outliers in our data? Yes, we do. How do we want to handle outliers? That's a discussion to have with your data analytics team. Do we want to remove them? Do we want to impute them, which means change our outliers, etc.? Okay, so we have our bar chart. We have our box plot. What about a histogram? A histogram is very good when you want to see the distribution of a single numeric variable. And we're also going to use seaborn for this. So we're going to call sns.hisplot, and we are going to call students in the GPA column again, which was the same column that we did for the box plot. And now we can see the distribution. And we see that it's not symmetrical. This may be important when we're doing any type of modeling or statistical test for us to know. And it also can help us see if there are potential outliers. Okay, so both of these are great plots. Now, what if we want to look at the relationship between two variables, which in this case is going to be the relationship between someone's Calculus 1 performance and Calculus 2 performance. And in a future video, we could talk all about covariance and correlation and how correlation doesn't mean causation. But right now, when we have two numeric variables, it's ideal to do a scatter plot. And I'm actually going to do this in matplotlib. So in this case, I have my fig and my x objects, and this is just creating a figure object, and the x means the axes, so the x-axis and the y-axis, and I'm just creating those. And then on the axes, I want to have the calculus 1 score on one of the axes and the calculus 2 score on the next. And then I want to actually show this plot, and this is what I get. Okay, and I see that there looks like that there is a positive correlation, weak positive correlation perhaps between the two. That if you perform well in Calculus 1, you're also performing well overall in Calculus 2, which makes sense. Okay, so this is how we do a visual in matplotlib, and I challenge you to play around with these column names. Do Calculus 1, and I think we have statistics. All right, and see if we see any relationship there. Instead of you looking at a histogram of GPA, let's look at a histogram of probability, which is also in our data frame, right? And we see that there's some interesting things going on within the probability class, right? So explore your data using data visuals, okay? All right, so let's go back into the notebook that we have here. We visualize some data. The next step is going to be creating variables, and this is optional. Sometimes you don't have to create variables to add to your data set. Sometimes you may want to create variables. So we're going to create an average calculus performance variable, and we're going to call that variable average underscore calc. So how do we do this? So on the left-hand side, we call the name of the data frame and the name of the new column that we want to make, which is average underscore calc. We're then going to set that equal to our mathematical formula. So in this case, I want to take their performance in Calculus 1, their performance in Calculus 2, and add them together, and then divide this by 2. That way I can get their average calculus performance. So I'm going to run that. And in order to print it out, I am going to do a dot head. So I'm going to do a dot B. I'm going to do students, right? Once again, we're going to call that dot head method. And at the end, I see average calc. Now, does this look like their average calc score? 81 plus 87 divided by 2, does it give you 84? It most certainly does. So creating variables is just as easy as calling the new name of the variable on the left-hand side and setting that equal to whatever you want it to be. Maybe you want it to be equal to a string, right? So say, for instance, we wanted to create a variable called country. We can say students, country, and let's just say all of them are from the US. We could just assign it USA. And then when we do the dot head again, we see that we have USA there. Okay, so you can create any variables that you would like. Outside of creating variables, we can also drop variables. So creating variables helps us add variables to the data frame. Dropping variables, of course, will drop the variable out. So say, for instance, our client doesn't want us to consider functional analysis because they realize that the grades weren't finalized. So we're going to go ahead and just drop that from the data frame. There are going to be a second argument within this method. If the axis is equal to 0, that means that you're dropping a row. If the axis is equal to 1, that means you are dropping a column. So let's see how this works. So in this case, I'm assigning the data frame object students, and I'm setting that equal to students.drop. And I'm going to have the name of the variable I want to drop, and I'm going to have axis equal to 1, and I'm going to run that. Now, does it work? As always, let's check the head. We're going to do students.head, and functional analysis was right here, and I no longer see it. So it definitely did work just by calling that dot drop method. All right, so we have read in data. Once we read in the data, we created a data frame object and checked the type. We have done a dot head, a dot tail, a dot info to explore the data. We have done dot describe, dot crosstabs, dot value counts, dot group by to get some statistical summaries of the data. We have used Pandas, matplotlib, and seaborn to visualize the data. We have created variables. We have dropped variables. And now it's time to write out our new data frame, okay, to a CSV file. Why do we want to do this? So we don't have to keep going back and redoing this analysis. We want to make sure when we save this file, we save it as a new name as to never overwrite your original data. You want to keep the original intact. So how are we going to do that? With a nice little method here, students dot to underscore CSV. I want to save it right in the directory where I'm at. So I'm just going to call mine new students with the date on there, and I'm going to run this. And then when I go to my directory, I should see this new students pop up. And that is going to be my new data file that I can read in with a read underscore CSV. Awesome. So let's do a quick summary. Pandas is a great package for data exploration and manipulation. Everything in Python is an object, and based off of the objects, you have specific methods and attributes. Today, we work with the object called data frame that has certain methods like dot head and dot tail, and certain attributes like dot shape and dot columns. Those are specific to data frame. So do series have it? Not necessarily. Do integers have it? No, they don't. So make sure you know what types of objects you are working with. Statistical summaries are great in exploring data. Visuals can help you explore your data even more to paint that clear picture. So every time you explore things, ask yourself, what is this telling me? Variables can easily be created and dropped by using Pandas, and you can spend tons of time exploring your data, but not just what's in your data. Think about what's also not in your data and if there are any biases. So, with that being said, thank you all for tuning in to Learning with Jelly. as I mentioned, if you enjoyed this crash course, please comment below. We can create more crash courses to help you get into that field of data analytics and data science. So please, please, please share, like, comment, and subscribe. If you're having any problems with GitHub or any problems running your code, try researching it first, okay? Go to the Pandas documentation, look at the GitHub documentation or tutorials to try to troubleshoot, right? That's just going to help you learn even more. So thank you all. Please like, comment, and subscribe, and I will talk to you all soon. Thank you so much. Bye-bye.